Hello everyone, and welcome to this in-depth look at water management in hydraulic fracturing. In the next 8 minutes, we'll explore why water is such a critical component of this energy extraction process, from sourcing to disposal, and the environmental considerations involved. Let's start by understanding where the vast amounts of water needed for hydraulic fracturing come from. The primary sources for fracking water include freshwater aquifers, surface water bodies like rivers and lakes, and even recycled industrial wastewater. The choice of source often depends on regional availability and regulatory frameworks. Acquiring water for fracking operations is a complex process. It involves navigating various local, state, and federal regulations, securing permits, and addressing potential environmental impacts and community concerns. Once sourced, water is meticulously prepared for use in the fracturing process. This involves careful treatment and mixing with proppants and chemical additives. The volume of water required per well can vary significantly, typically ranging from 2 million to 6 million gallons. This volume depends on the geological formation, well depth, and specific fracturing techniques used. During the fracturing process, the water, mixed with sand and chemicals, is injected at high pressure to create fractures in the rock. This allows natural gas or oil to flow more freely to the wellbore. The water also transports the proppant into these fractures to keep them open. After the fracturing process, a portion of the injected water returns to the surface, along with formation water. This is known as flowback and, produced water. This water can contain dissolved solids, hydrocarbons, and naturally occurring radioactive materials, making its management a critical step. Effective water management in hydraulic fracturing relies heavily on advanced treatment technologies to handle flowback and produced water. Common treatment methods include physical separation, chemical precipitation, biological treatment, and membrane filtration. These processes aim to remove contaminants, allowing for potential reuse or safe disposal. Treating this water has several benefits. It reduces the need for fresh water sourcing, minimizes environmental impact, and can lower operational costs by enabling reuse in future fracturing operations. Water recycling and reuse are increasingly becoming standard practice in the fracking industry, driven by environmental and economic considerations. The concept of closed-loop systems involves treating and reusing all flowback and produced water, significantly reducing the demand for fresh water and minimizing waste. This approach promotes sustainability and efficiency. The advantages of recycling water are numerous: decreased reliance on freshwater sources, reduced disposal volumes, lower transportation costs, and a smaller environmental footprint. It's a win-win for both the industry and the environment. When water cannot be reused, it must be disposed of safely. Common methods include deep well injection into approved geological formations, or, in some cases, discharge into surface waters after extensive treatment to meet regulatory standards. Environmental considerations are paramount in these processes. The environmental impact of water management in fracking includes potential for groundwater contamination, surface water depletion, and induced seismicity from deep well injection. Mitigation strategies involve stringent regulations, advanced monitoring, and continuous innovation in treatment and recycling. The regulatory landscape for water management in hydraulic fracturing is complex and constantly evolving. Key regulations, such as the Clean Water Act and Safe Drinking Water Act, govern water use and disposal. Industry best practices emphasize minimizing water consumption, maximizing recycling, and transparent reporting. Looking ahead, the future of water management in fracking is focused on continuous improvement and innovation. Emerging technologies include advanced membrane separation, electrochemical treatment, and even waterless fracturing techniques like using liquefied petroleum gas or compressed air. These innovations promise even greater efficiency and reduced environmental impact. The industry is moving towards more sustainable practices, aiming for zero liquid discharge, increased community engagement, and further integration of digital tools for real-time monitoring and optimization of water resources. In conclusion, water management is a critical and continually evolving aspect of hydraulic fracturing. From sourcing to treatment and disposal, every step is vital for operational efficiency and environmental stewardship. Thank you for watching.